Hey everyone, welcome to Driven Math and Physics. So today we'll be looking at work, energy, and momentum problems. And so the first question that we have is, a tennis ball is dropped from a height of 2.5 meters. So the initial height is 2.5 meters, okay? And then height 2 after rebound is 1.6 meters. So this thing drops, then rebounds, okay? So if the ball is there, the initial height, this is 2.5 meters, and then it rebounded to 1.6 meters, okay? But it wasn't able to bounce back to its original height. That means there's energy lost there. That's why they're saying calculate the percentage of energy lost during the bounce. Okay, now we have not been given any other information, only the heights. What they were trying to drive at here is trying to show us that it's possible for you to analyze energy changes by simply looking at the height changes. And that will give you a depiction of how potential energy is changing throughout the process. Okay, so let's track that. We know that potential energy is equal to mass times g times height. So if we look at the first potential energy for the first height, that is original, it will be m times g times the first height is 2.5 meters. Okay, now potential energy 2 will be equal to m times g times the other height is 1.6 meters. All right, now if we want to find the percentage of the energy, that is conserved on the rebound, it will be potential energy 2 divided by potential energy 1 times 100%. This one will give us the percentage of the energy that has been retained or kept or conserved after the rebound. Okay, so how much energy was here at 1.6? That's what we're going to find here. Not the value itself, but the percentage, okay, from the original amount of energy. Now from there, we're going to do m times g, that's potential energy 2, this is the expression, times 1.6 meters, divide by m times g, this one, times 2.5 meters, this multiplied by 100%. Okay, so from here, what we'll notice is, we're going to start calculating here. The m and the g's are the same because it's the same object. So 1.6 divided by 2.5, you find 0.64 multiplied by 100%, which gives us 64%. But now, energy lost, percentage of energy lost will be equal to 100% minus 64%. This gives us 36%. So that is the percentage that they were looking for in part A. And then they're saying explain how the loss of mechanical energy is accounted for in terms of energy transformations. Okay, so they're asking us to say what contributes to the loss in mechanical energy. Not necessarily what contributes, but what does the mechanical energy that is lost become? That's what they want you to find here. What does it become? So some people say it can be lost in form of what? Heat, sometimes sound, and also you will learn later on that it's also lost because of the deformations that happen upon collision. Okay, due to the deformations that happen upon collision. So that's how you do this problem. Okay, let us move to the next one. Okay, I hope that is making sense to you. So let's move to the next question. Let's move to the next question. So the next question says, a 1,200 kg car is moving at 18 meters per second, crashes into a stationary 800 kg trailer. The two bodies lock together after collision. Calculate the common velocity immediately after collision. Okay, now I want you to follow me here. So what we have is mass 1, which is a car. Okay, so we'll say MC. All right, that one is 1,200 kgs. All right, U1, which is UC, mass, the velocity of the car, initial velocity, is 18 meters per second. And then we have mass of the trailer, which is equal to 800 kgs. Okay, from there, we don't know anything else. All right, now they're telling us that these two things, one is moving, the other one is stationary. So if we're going to write the expression for the conservation of momentum, the law of conservation of linear momentum, we're going to write it as mass of the car times initial velocity of the car plus mass of the trailer times initial velocity of the trailer should be equal to, so what we know is they're locked together. That means their mass becomes common. So it will be mass of the car plus mass of the trailer multiplied by common velocity. So they want us to find this V, which is the common velocity. This expression right here is the law of conservation of momentum. And from there, what we're going to see is that we know MC, which is 1,200 kgs multiplied by initial velocity 18 meters per second. Okay, and then we're going to find that the mass for the trailer is also given 800 kgs, but remember it was stationary, so it had no initial velocity. Now the total mass here is actually 2,000 kgs multiplied by V. Okay, so from there it will be let's do 1,200 multiplied by 18. This gives us 21,600 kg meters per second. This becomes 0, which is equal to 2,000 kgs times V. Divide by 2,000 kgs. Divide by 2,000 kgs. That means V will be equal to so that will be 21,600 divided by 2,000. This gives us 10.8 meters per second. That's the common velocity. Now they're going to ask us here that we should calculate just give me a moment. I need to calculate the total energy before and after the collision, determine the energy loss due to collision. Okay, so what we're going to do is, remember, let's write this somewhere. We know that the common velocity is equal to 10.8 meters per second. Okay, what else do we know? I think we know that mass 1 equals 1,200 kgs. That mass of the car, of the trailer, is 800 kgs. Okay, now we can remove this for now. So we need to find the kinetic energy before and after collision. So first of all, we're going to find before collision. Okay, before collision. So kinetic energy will be equal to total KE, not change in KE, sorry. Okay, so that will be equal to half times mass of the car times initial velocity of the car squared plus half times mass of the trailer times initial velocity of the trailer squared. So that will give us half times mass of the car is 1,200 kgs multiplied by initial velocity of the car. If I remember very well here, I think, let me just push it up a bit. We're given 18 meters per second. So we know that that initial velocity is 18 meters per second squared. This thing becomes 0 because the initial velocity of the trailer was 0. So from there, this into this, we get 600 kgs. So what we're going to do is 18 to the power 2. That gives us that multiplied by 600 it gives us 194,400. This one is joules. Okay, that's the initial. Now after collision, okay, these things stick together, so the total kinetic energy will be half times mass, okay, which is total, times common velocity squared. So this will be equal to half times 2000 now. That's the total mass multiplied by common velocity, which is 10.8 meters per second squared. This into that, that's 1000 kgs. Okay, so if we do 10.8 to the power 2, that gives us that multiplied by 1000. Okay, let me just do it properly. Times 1000, that gives us 116,640 joules. Okay, now what they want us to find now is the energy right here. Let's follow through this. They determine the energy lost. Okay, determine the energy lost due to the collision. So we're going to see what we started with is what we end up with. Okay, so energy lost will be equal to initial minus total kinetic energy final. Okay, so that will be equal to 194,400 joules minus 116,640 joules. This gives us 77760 joules. This was the amount of energy that was lost. There are two reasons why energy is lost during collision. Now, because that energy is literally converted to what? Heat, sound, and some of it is lost due to the deformation that happens when two things collide. Okay, so that's how you do this. It's really straightforward as long as you account for everything that you're given. Now, let's transition to the third problem. I hope you're able to follow this, and make sure you do these problems before I actually show you how to do it. In that way, you'll actually be able to know whether you're improving or not. Okay, this is very important, very important. Now, let's look at this next one. He says, a 2 kg cart moving at 3 meters per second on a frictionless track collides elastically with a stationary cart of unknown mass. After the collision, the 2 kg cart rebounds at negative 1.2 meters per second. Determine the mass of the second cart. Okay, so let's see what we're given here, people. Let's see what we're given, because that will really help us in seeing what method we're supposed to use. Now, first of all, we know the mass of the cart. Okay, so let's write mass of the cart is equal to 2 kgs. Okay, now what else do we know? We know the mass. Do we know the mass of the? No, it's actually carts, all of them. So let's do number 1 here. Okay, that's the mass of cart number 1. Number 2, we don't know. We're not given. Then we know that initial velocity of cart number 1 is 3 meters per second. All right. Initial velocity of cart number 2, we don't know. Okay. Do we know? Yes. So it's 0 because this thing was stationary. Okay, good. Then from there, after collision now, okay, do we know the velocity of the initial cart? The 2 kg cart, yes, is equal to negative 1.2 meters per second. What about the velocity of the other cart? We are not aware of this thing. Okay, now, it's very important. We're not given mass, we're not given the velocity. So, we need to calculate the mass of the second cart. Let's write an expression for the law of conservation of momentum. So, it will be m1 times u1 plus m2 times u2 equals m1 times v1 plus m2 times v2. All right, so what are we given? We're given mass of number one, 2 kg multiplied by 3 meters per second, plus this thing right here becomes what? 0, because this thing is stationary. So it's equal to, the mass of 1 is 2 kg v1, okay, multiplied by negative 1.2 meters per second, plus these ones, we're not given anything there. We don't know anything. Okay, so from here, this times that is 6 kgs meters per second. That will be equal to, so 2 times 1.2, 2 times 1.2, that gives us negative 2.4 kg meters per second plus m2 v2. Then from there, this can go that side. When it goes that side, it will be m2 v2 equals 8.4 kg meters per second. Why? Because when it goes that side, it will become positive, and they will add. That will be the solution right here. So this will label it as equation number 1. Okay, so let me write it here. m2 v2 equals 8.4 kg meters per second. Okay, now from there, what we're going to do is, we don't know so many things. Maybe we're going to try and come up with another equation by using the conservation of kinetic energy. Why? Because they have also told us that this thing has gone through a collision that is elastic. So we're expecting that maybe there will be a conservation in the kinetic energy as well. Okay, so let's do that. Now it will be half m1 u1 squared plus half m2 u2 squared equals half m1 v1 squared plus half m2 v2 squared. Okay, this becomes 0, and this will be half times 2 kgs multiplied by 3 meters per second squared equals, okay, this will become half times 2 kgs multiplied by negative 1.2 meters per second squared. Okay, let me just remove that part. Negative 1.2 meters per second squared. Then here plus half m2 v2 squared. We don't know that part. All right, so this into that one, same thing there. And then here it will be 9 kg meter squared second squared equals, then there 1.2 to the power 2, that gives us 1.44 kg meter squared second squared plus half m2 v2 squared. Okay, so when this goes there, it will subtract, so that will be minus 9. Okay, so that gives us half m2 v2 squared equals 7.56 kg meters second squared. Okay, so from there we multiply both sides by 2. Okay, that will be m2 v2 squared equals 15.12 kg meter squared second squared. Okay, now what you're seeing here is a formation of 2 equations. Okay, 2 equations. Now let me remove this part right here. Just need to remain with the equations. Okay, 2 equations. Now we need to find the unknowns that are in there. Let's make m subject with the formula. Okay, m2. So because what we want to find is the mass of the second card. Okay, so it will be, now let's make v subject with formula. Maybe that will help. That will be v squared, v2 is equal to 8.4 divided by m2. So that should be substituted where? There. So it will be m2 8.4 divided by m2, this is squared, equals, so where there was v, we've substituted this thing right here. Let me write it properly so it can be very clear to you. Okay, so it will be 8.4 divided by m2 squared. This should be equal to 15.12. Okay, so that will be m2 times, let's do 8.4 squared. That gives us 70.56 divided by m2, okay, equals 15.12. This will be squared, so you cancel 2, you remain with 1. Okay, so that will be 70.56 over m2 is equal to 15.12. I hope that has not confused you. All right, so from there we are going to have to make m2 subject a formula. So it will be so this part goes here. It will be 70.56 divided by cross multiplication, 15.12 equals m2. Okay, so this divided by 15.12. So m2 becomes, let me write it here, m2 is equal to 4.667 kgs. Can you see that? That's the mass right here. That's the one that we're looking for in part A. In part B, we need to find velocity now. We know that v2 is equal to this, 8.4 divided by m2. That will be 8.4 divided by 4.667 kgs. This is kg meters per second. The kgs can cancel out. So that will become 8.4 divided by 4.667. That will become 1.8 meters per second. This right here is a velocity that they were looking for in that part. So this is how you go about it. I want you to tell me in the comments, is this really complicated? Is something that is difficult for you to understand? If you didn't get something I said, just try to rewind or maybe leave a comment and I'll respond to it accordingly. And so this is what I had for you today. And continue to follow the channel. Thank you.